Hello everyone, I'm Miss Mousami Vanjale, Assistant Professor in Department of E&TC Engineering of AISSMS Institute of Information Technology, Pune. I welcome you all for my series on Mechatronics concepts. Today I am going to explain the concept of accuracy and precision, the two most important static characteristics of a measurement system. To choose an instrument or a measurement system most suited to a particular measurement application, we have to know the system characteristics. The performance characteristics may be broadly divided into two groups, namely static and dynamic characteristics. The static characteristics is nothing but the performance criteria for the measurement of quantities that remain constant or vary only quite slowly, while the dynamic characteristics is the relationship between the system input and output when the quantity under measurement is varying rapidly. Let's discuss on the different static characteristics of the measurement systems. There are various static characteristics such as range, full scale, accuracy, tolerance, precision, repeatability, reproducibility, sensitivity, sensitivity to disturbance, linearity, hysteresis, date space or threshold. Today we are going to discuss the two most important static characteristics, that is the accuracy and the precision. Accuracy of an instrument is a measure of how close the output reading of the instrument is to the correct value. Manufacturers quote the inaccuracy figure rather than the accuracy figure for an instrument. Inaccuracy is the extent to which a reading might be wrong and is often quoted as a percentage of the full-scale reading of an instrument. The inaccuracy can be calculated using the formula max error divided by full-scale reading into 100%. To understand the concept better, consider the example of a temperature measurement using a thermometer. If the inaccuracy of the thermometer is stated, then the actual temperature may not be equal to the correct reading of the temperature. For example, if the correct reading is equal to 25 degrees Celsius, then the thermometer with the inaccuracy could measure the value between 23 degrees Celsius and 27 degrees Celsius. So there is a variation of the value from 23 to 27 degrees Celsius. To understand further, let's consider the example: a pressure gauge with a range of 6 to 10 bar and an inaccuracy or error of plus minus 3% is used to measure the pressure in a tank. If the reading of the gauge is 7 bar, what are the maximum and minimum values of the actual pressure in the tank? We know the equation for inaccuracy is equal to max error upon full-scale reading into 100%. In order to calculate the maximum error, the equation is rearranged as max error is equal to full-scale reading into inaccuracy, that is equal to 10 minus 6 into plus minus 3%, which comes out to be plus minus 0.12 bar. Hence, the maximum value of the actual pressure can be equal to 7 plus 0.12, that is 7.12 bar, and the minimum value of actual pressure will be 6.88 bar. Thus, the measured value may vary from 6.88 bar to 7.12 bar instead of the correct value of 7 bar. So, we need to select an instrument or a measurement system depending upon the tolerance of the application to the inaccuracy or the error. Let's move on to the next important characteristics, that is precision. Precision is a term that describes an instrument's degree of freedom from random errors. Suppose we take a large number of readings of the same quantity. Then the difference between any two readings must be as small as possible. The readings must be closer to each other. Then that instrument is said to have a high precision. A high precision instrument may have a low accuracy. For better understanding the concept of precision, let's consider the examples. Here it is seen that the multiple readings taken are closer to the accurate value, as well as the readings are closer to each other. This indicates that this measurement system is accurate as well as precise. While in the second example, we can see that the multiple readings are equidistant from the correct value, but the distance between any two readings from the set is not same and it is quite large. Thus, this kind of system is accurate but not precise. In this third example, we can see that all the sets readings from the set are closer to each other, but they are away from the accurate value or correct value. Hence, this system is not accurate, but it is precise. In the last example, it can be seen that the multiple readings of the same quantity are away from the correct value as well as they are away from each other. The difference between any two readings is large as well as these readings are away from the correct value. Hence, the system is said to be not accurate and not precise. Thank you.